Hey, what's up, guys? Hope everybody's doing well and having a great day. In this live stream, we're going to touch on a variety of different topics, from the sun angle to the sun itself. What you're looking at now is a video clip of Hurricane Hannah's landfall in the Corpus Christi, Texas area. This video footage was shared with me by Adam. I've actually got a couple of small video clips I want to show you guys of the footage that Adam was kind enough to share with me, so the least I can do is share it with you guys. So here it is. It wasn't a major hurricane, as you guys all well know. It's a Category 1 storm, but it did rapidly intensify from a tropical storm to a Cat 1 hurricane, making landfall in the Corpus Christi area. From what I understand, 12 to 18 inches of rain in some places, eventually going over into Mexico. Here you can see some storm surge making its way across the highway in the Corpus Christi area. Got another video I want to share with you guys from Adam as well of Hurricane Hannah's landfall. We're also going to look at some photos that I've received recently, like you saw on the thumbnail, and some other photos of like sun damage photos, I guess. Don't know how else to describe it. I'll share those with you here in a moment. Here's another video of the Hurricane Hannah landfall. Get to it here. Also in this video, we're going to try to take some questions. Have a little question and answer, if I can answer some good questions related to Earth changes, sun angle, weather, and things like that. The things that we like to talk about here at this YouTube channel. Here's some more footage of Hannah making landfall. And again, like I said, it wasn't a major hurricane, which was great, but did bring a lot of rain to the South Texas area, parts of northern Mexico. I think I saw 18 inches of rain in some places, which is quite extraordinary. We've got another storm brewing down south of the Caribbean. In fact, it's in the southern Caribbean islands right now. It's a strong low pressure. It's not officially a tropical storm yet, but the potential is certainly there. We're going to take a look at that here in just a moment as well. But there's the landfall of Hurricane Hannah. Thank you, Adam, for sharing that. I really appreciate it. Going to hop over and take a look at the Schumann resonance here in just a moment. Got a little bit of activity in the Schumann. I'm not 100% sure what's going on or what's instigating the activity in the Schumann, but we'll take a look at it and see. Solar wind isn't up. There's no Earth-directed solar flares. Not too much really going on in that regard. Gonna hop over to the website now. We're going to look at the Schumann and Yellowstone and then go from there. I want to show you guys some pictures that have been sent in recently of different things that show some pretty intense sun damage, like on a piece of, or a bell pepper, for instance, like you guys saw sent in by Sherry Tapscott from New Jersey. We're going to come back to that here in a moment. Here's the Schumann data, the most recent, and you can see there is some activity currently underway right now as I do this video. No Earth-directed solar flares that I know of, no CMEs, no. I think there was a small sunspot, but we are still well in solar minimum, and we will be for a while, so don't know what's causing the increase in the Schumann resonance. Could be a variety of things. I'll leave that up to you guys to decide. Hopping over to the Yellowstone supervolcano. Another day at the caldera. Business as usual. As you guys can see, a variety of energy moving through the caldera. Got energy in the resonance, and we've also got energy moving through the supervolcano. This here is quite extraordinary. And this location is over at Grayling Creek. This would be on the northwest side of the supervolcano. I mean, there's so many there you can't even count. I know they're not earthquakes. It's probably some form of magma intrusion. some sort of activity in the ground on the northwestern edge of the supervolcano caldera. That site is exceptionally busy. You can see here at Norris Junction, a little bit of activity there. Then if you go down to where you would think there would be activity, it's pretty much, for the most part, all quiet. And you're looking at the seismo at the Old Faithful location. And that is the most active, well, at least the most obviously active area, or one of the most active, with regard to geysers at the caldera, and it's generally pretty quiet. So a lot of activity here at the supervolcano. As usual, that seems to be the new norm instead of the exception. I want to hop over here to spaceweather.com, and we're looking at solar wind speed. You don't see anything that would imply any type of resonance or influence in the Schumann resonance. I mean, that's quite normal, 346 kilometers per second. That's right at average. Density at 7.0. That's actually average as well. Nothing here extraordinary that would think would show anything that would be influencing the Schumann resonance. Got some near-Earth objects that came very close to the Earth yesterday on the 28th. I don't know if you guys noticed the quick uptick on the 28th. There were 4. I think there was 1 already. We got 1, 2, 3. Yeah, 4 on the 28th of July. 1 at 0.1 LD. And that is between the Earth and the Moon system. 0.1 being much closer to the Earth than the Moon. 1 LD is 1 lunar distance, which would be, let's just say, 230,000 miles. That's 1 LD, 1.0. 0.1 is 1/10 of a distance between the Earth and the Moon, so that would be approximately 23,000 miles above the surface of the Earth. But again, it was very, very small, coming in at 3 meters. I'm surprised they even saw that. Maybe it skimmed the atmosphere in some degree. I don't know. Very, very close. Didn't impact. I'm surprised, being that small. A lot of times, those can be gravitationally influenced by the Earth and actually pulled into the atmosphere. But apparently it did not. It went right on by. Got another one for September 1st at 0.3 LD. This one's a little bigger. In fact, it's about 10 times the size of the one that just went by the Earth yesterday at 30 meters. So that'd be about 90 feet. That's pretty good size. So we'll be watching the skies pretty close on September 1st, at least extra close. We watch the skies very close anyway. But a lot of times, these, like you saw here on the 28th, they have buddies. They travel in packs of 2, 3, 4, sometimes more. And we may see some activity in the skies, albeit small, but you might see some fireballs here and there on the night of the 1st or the 31st into the 2nd. We'll have to wait and see. Speaking of the sky, dark red noctilucent clouds have been spotted in northern Europe. I think this was over in Sweden. I don't know if you guys saw this or not here at spaceweather.com. Excellent website. You can find it linked below in the description box. But noctilucent clouds are very popular this time of year. There's actually a noctilucent cloud season, and they're typically only visible well in the northern hemisphere. And you can see an example looking down at the North Pole from a spacecraft orbiting the Earth. There's what the noctilucent clouds look like. They're glowing. They call them electric blue clouds. That's the term for noctilucent clouds, and they're normally blue. All right. Well, for some reason, some were spotted over Sweden back on the 25th that were red. And I just wanted to throw a guess in the ring just for whatever purposes. I think that's being influenced, or that color is being influenced by the massive Saharan dust layer that's literally spreading all the way up into northern Europe and parts of Sweden. And I'll show you guys here in a minute, but I think that's what's causing that phenomenon. There's a view from June 21st from above Poland, and you can see reddish noctilucent clouds. They're not the standard electric blue. That has to be sand from the Sahara Desert. At this point, they don't really know what's causing that, but here's the sand from the Sahara, and you can see it extends all the way up into the Mediterranean Sea, up into Europe. At the time when the noctilucent clouds were visible, there was probably a pocket of Saharan dust in the sky in that area, creating a reddish effect. And noctilucent clouds in the northern hemisphere are, again, it's the sun angle. The angle of the sun is leaking over the earth, creating this electric blue sky phenomena. That's all it is. That's why there's a noctilucent cloud season. That's why we don't have them in the northern hemisphere in the winter, because of the sun angle. Sun angle is much different. So that's, for whatever it's worth, that's my 2 cents on that. And since we're over here on the Saharan layer, I want to bring this up real quick. And I'm also trying to look at questions too, guys. So keep them coming. I'm going to answer a few. Obviously, I'm not going to be able to get to them all, but keep them coming. I appreciate it. Hang on just a second. Okay, guys, I'm just checking something out. I'm sorry. I'm right here. In fact, I was looking at some questions. So bear with me. But I want to talk about this layer of dust and the sun angle. It's influenced by the sun angle. I don't know if you guys figured that out. You probably already knew. But that's influenced by the sun angle. It's no coincidence that started right around the equinox, around June 20th, 21st, and that's when the sun's at its peak in the northern hemisphere. And what's the peak? 23.5, right? Well, guess where the Sahara's at right there? That's 20, 22, 23.5, right there where my mouse is at. See that? That's exactly the point of the equinox. I got a question from Arizona Raven. Should the sun be rising in the northeast today? No, it should not. The sun angle, which I'm going to show you guys in this video, a simple way to check the sun angle and see if the sun is moving south. It's definitely moving south. I'm 100% confident on that. I have proof. I measured the sun angle shadow back on the equinox, June like 19th, 20th, 21st. I measured the angle, and then I measured the angle again yesterday, and the angle of the shadow. And the shadow grew by 1.5 inches in 5 weeks. And that tells me that the sun has to be moving back towards the south. So the sun should not be too far in the northeast, maybe a little depending on your location, but it's definitely moving back to the south. That's why hurricane season is picking up. Everything is all about the sun angle, or at least a big part of it. But this right here is causing the earth to heat up. Yeah, this needs to stop. It really does. It's hard on the earth's cooling system. Another question from Kitty Rose, asking if I've seen any earthquake activity in the Pacific Northwest in the past few days, and not really. And it has been pretty quiet up there. We're kind of in a neutral zone in space, if you will. At least that's the way I like to interpret it. I'm kind of a self-taught guy on some things, and I do know that the planets do communicate with each other electromagnetically, and we're in a neutral zone right now. So yeah, it's pretty quiet. Got a question from Carmel Lewis. How much has the sun and moon changed? How much has the angle changed in comparison to this time last year? And I don't have any exact data to give you a correct answer on that. I mean, I don't know. To me, it seems like the sun was maybe a little bit higher this year. I don't know for sure, but it did seem like it was to me. But we're going to come back to that here in a minute. I want to show you the sun angle and how I know that the sun angle did, in fact, move to the south considerably just over the last, I don't know, 5 weeks, 2 weeks, to be honest. I've got some photographs of the sun angle. Check this out. What you're looking at is a photo that was sent in by Sherry Tapscott out of New Jersey. And you're looking at, obviously, a bell pepper that got singed somehow. Had a hole burnt right through it. Right through it. Looks like, to me, is from direct sunlight, right? I'm just getting some pictures here together, guys, that's all. And I'm trying to assemble some of your questions. You guys keep them coming. Thank you, Dan. You're welcome, Dan. My pleasure. Getting together a few photos here, guys, and a few questions. You're looking at a pepper. What do you think happened to that pepper? Sherry says that pepper was facing south and basically happened in one day, overnight. Joe Yamada asked, how tall did the alien asparagus grow that we were measuring in the front yard? It grew to 136 inches, Joe. And it stopped, and now it's flowering out. In fact, I've got a picture somewhere. Let me see if I can find it, of the blooms. Here they are. It's a picture I took at night. I'll show you what it looks like. It went up to 136 inches tall. In fact, I just found the picture. I'll show it here in just a moment. And stopped growing. Kind of neat. I've never seen that plant out there in particular. Has never done that. Muggsy777, what about the incoming asteroids and rising sea levels? Right now, Muggsy, I'm not aware of any major asteroids. I keep hearing they're behind Jupiter. They're tucked in behind Jupiter, but we're looking into that. I'm working on something, so just bear with me on that. Got more questions coming in. Keep them coming, guys. Super Flash. Super Merla. Do you think the Starlink have anything to do with weird radar signatures that I've shared previously? Thank you for the question. You know, and that's a good question. One that I've never really thought about too much, because I've seen weird, so to speak, radar signatures for quite some time, even well before Starlink. So I would have to say probably no on that, just simply because I've seen weird radar signatures over the years. I've been following radar for a long time, and radar's improved a lot just in the last couple of years, but I don't know. I know they interfere with observatories that may be doing very in-depth studies of long-range galaxies and star systems. And then here comes the Starlink train flying right through the sky in front of their field of view, totally interfering with their research. I mean, talk about a mess. I don't know if if it's worth the interference that people are dealing with. I don't know. It must be something very important. Trying to get internet up into the, Mount Everest and the Andes Mountains. Should we expect asteroids hitting the Earth? Don't expect any right away. Okay, that's all I'm going to say on that for now. Justin805, what do you think about the event that happened in Fatima? How do you explain that? I'm just reading over some of the questions here. Lee Dement, where would the sun be now if the Earth's tilt has increased? Well, the sun would be more north at sunrise and sunset. Exactly. It would be considerably more north. But if you pay attention to satellites, you can see the sun, the direct sunlight on. In fact, I'll try to bring it up and show you guys here. And I followed it this year, and the sun is in fact going back down now, at least towards the equator. It's not rising anymore. It did stop around the 23.5 degree north, which is above the Sahara Desert. So, and that's what influences that dirt, that sand, that Saharan air layer that's flying over the Atlantic. It's unreal. And that's influencing the warming of the globe, I think. Okay, yeah, you can see it right here. I'll show you guys here in just a second. You can see the sunlight, the direct sunlight. It's over Panama right now as it's moving across the Earth, but we'll come back to that here in just a second, guys. You keep the questions coming, and I'll do my best to answer them and still do the video. What you're looking at now is a photo I received out of Baltimore. This photo was sent in by Susan, and obviously that's playground equipment. And this is one of the reasons that years ago, or 4 years ago, I started doing UV readings. When people are sending me pictures of things like this, you know, you're trying to look for things that could cause it, you know what I mean? So one thing that we can all easily look at is the temperature. We can look at our phone, we can watch the weather, we can look at your outdoor thermometer, and we can easily identify how hot it is in any specific location, all right? So I was looking for something other than heat that could maybe influence, you know, playground equipment getting melted like that. That's unbelievable. So I decided to measure the UV. Here's another example I want to show you guys of the same type of thing. This was sent in by a young lady out of, let's see how well you can see or not. Sent in by a young lady out of West Virginia. Her name is Sharon, and she walks, this is along a creek bed. She's been walking this creek bed for many years, and she noticed rocks in the creek bed, and this is just from this past week. She noticed rocks in the creek bed, I don't know how well you can see that or not, that were singed. They had burn marks on them. And she walks this every day. And it's not a place where you go camping. There wouldn't have been campfires there or anything like that. And there were some that were just random. This was one area where it was kind of concentrated. There were several rocks and one that looked like it had completely ignited. Can you see that? See if I can get in a little closer. Okay, there's a little closer. I don't know, what do you guys think? This is what I'm trying to interpret. I get pictures from people quite often of different things, and you know, I do my best to interpret what we're looking at. I've never seen a rock, unless that's coal. That's the only other thing I could think of. That could be a piece of coal, because there is coal mining out there that quite possibly may have lit up. I don't know. You tell me. Have you ever seen that? I haven't. Yeah, I have at campgrounds. Of course, we all have. But I have never seen a piece of coal just sitting out in the middle of the afternoon just combust and start, you know. Never have seen that. And neither had she. That's why she took the photo and shared it with me. Equine Prepper. I still do the UV readings. In fact, we're going to look at a UV reading, Equine, in this video. In fact, I'll show it to you guys right now. This is the UV reading that I did yesterday, and I want to kind of explain Why? I do the UV readings. You already know what compelled me to do the UV readings, and that's the photos that I received, not only from you guys, but observations that I made myself. I was seeing stop signs that were completely bleached white, and they all had a common denominator, and they all faced south, which tells us that they were in the sunlight, direct sunlight, all day long. And speaking of sunlight and sun angle, we're here at the GOES. This is a satellite that it's in real color. This is the true color, daytime, multispectral, and it's infrared at night. And you can see the sun angle right there. It's over Panama. There's the termination line, dark and obviously daylight. See right there over the northern part of Colombia into Panama. Right here it comes. And it did peak in the Sahara, which is at the 23.5 degree latitude. I did confirm it, which I do every year, and this year it was no different, even though it seemed different. I will say it definitely seemed different. But see the dust traveling transatlantic, it's getting thinner. And you know why? Sun angle. Everything's about the sun angle, guys. I mean, if you've never learned anything from me at all, just know one thing you did learn: everything is influenced by the sun angle. Everything. And this is no different. This Saharan dust layer, and this is what tells me that the sun angle maybe has changed to some degree, because back 10 years ago, 12 years ago, I don't remember 2-3 months worth of steady, non-stop Saharan dust making its way all the way over to Midwestern North America and the United States. Don't remember that. You can see right now, this is right now, there's a layer of dust in the Gulf of Mexico covering Florida. There's a big wave right there that's headed into the Caribbean, the Bahamas. These are the Greater Antilles, and this is where that storm's at right now, just west of the Lesser Antilles, right there. Will that storm, potential storm, become something? You know what? This storm here, it's a dark horse. It's a sleeper. This one here, you can't take your eye off of. We're going to come back to this Saharan layer in just a minute, but I want to talk a little bit about this storm, because this thing definitely has potential, all right? And I'll tell you how it could become something. There's got to be a series of events happen, and it's quite possible that they could. This thing here is massive. I mean, it is huge. So compared to the storm that was just down here, which was named Gonzalo, which was very, very small, and Gonzalo was just simply devoured by the Saharan dust layer. All right. This storm here, it's not a named storm yet. In fact, it's not even a tropical depression, but it's going to be, even in the middle of this huge dust layer. All right. Could even become a tropical storm, could become a hurricane. And I kind of think it will. We're just going to have to keep an eye on which direction it goes. If it goes up into the Gulf of Mexico, more than likely, this has a pretty good chance of becoming a hurricane. If it stays east of the Bahamas and east of Florida, then more than likely it's not going to become a hurricane. And the farther south this thing goes, and it's trying, I can just tell by its personality right now, you can tell it's trying to dip below like this 15-degree north latitude. It's trying to avoid the dust layer almost. And if it does, it will become more organized and could become a strong tropical storm, quite possibly a low-end hurricane. But it's going to encounter wind shear. And wind shear is not going to permit this thing from growing. Here it is right here. See the red? Not happening. No way. It's not going to happen. But if the wind shear shifts, then all bets are off. This could become a major storm. It has the potential to. Let's put it that way. Can the wind shear shift? Of course, it does all the time. And right up here inside the Gulf of Mexico, see the green, what look like isobars? Right up in here. Well, if everything were to stay the same and not change between now and the next 4 days, which we know that's not going to be the case, then if that thing makes it up into the Gulf of Mexico, conditions are nearly perfect for the formation of strong storms. We'll just have to wait and see. That one right there is a dark horse. So we can't underestimate that one. So we'll keep a close eye on that, which we always do. Always do. All right, guys, I'm going to try to take a few of your questions. Thanks for being patient. I'm trying to do what's extreme multitasking. But, back to the Saharan layer real quick. And right there's where that storm circulation's at. That's the reason I wanted to touch on that before it slipped my mind. But the Saharan layer is preventing storms, just like you're looking at right there, from basically doing their job. Storms, not only above the equator that we call hurricanes and typhoons, but south of the equator, which are cyclones, they're all cyclonic in nature. But what they are, they're a cooling mechanism for the Earth. And again, it goes back to the sun angle. When the sun angle reaches its peak at the equinox in the northern hemisphere, it's June 21st. Southern hemisphere, it's September 21st. And coincidentally, the southern hemisphere's cyclone season starts right around that same time that the sun starts its journey back towards the equator. Sun angle is changing, okay? The sun angle, when it starts changing in the northern hemisphere from 23.5 in the Sahara, and it starts its journey back down like you're seeing right here, you can totally see it right there. There it is. It's making its journey back down to the south towards the equator. When it does, it spawns these big circulators that we call hurricanes, tropical storms, cyclones. Those are heat engines. They're moving heat around the northern hemisphere, and they're actually influenced by the North Pole. The ones in the southern hemisphere are influenced by the South Pole. And they're transferring heat from the summer months around the northern hemisphere and around the southern hemisphere. They're transferring it around. They're trying to maintain balance with regard to heat. This Saharan layer is preventing these storms from doing their job, simply moving the heat away from the long, hot summer months and transferring it around the entire northern part of the sphere, the globe, the world, whatever you want to call it. Same applies down here. But when it can't move that heat around, guess what happens? The energy builds, and then you end up with one big, powerful storm like Dorian, like Irma. We had several that year that Irma formed, but Irma was exceptional. Dorian was exceptional. If you have a lot of smaller hurricanes, cyclones that can transfer that heat around, then you more than likely won't see big, strong, record-setting storms. That's what they do. It's a cooling mechanism for the planet. That's what they are. They're natural cooling mechanisms. Or at least they try to be. This big, dusty sand that's traveling across the Sahara, the Atlantic, needs to stop. It's causing the Earth to overheat. It's causing the Earth to overheat. Needs to stop. So I'm looking through some questions right now. Justin 805, polarity shift. Absolutely, it's done it before. Soul Vibe, does the dust add to or take away? Here's what I'm going to do, guys. I'm going to try to send a few of these questions your way, if I can. Okay, here's where we get some of the UV data from up here where I have it marked. That's Abbotsford, British Columbia, and that's where Darren's at. Darren sends me UV readings from there all the time. And believe it or not, his UV readings, in a lot of cases, not all, but a lot of cases are higher than what they are out here in Arizona. Not all the time, but 95. I would say 95% of the time, they are higher at the 50-degree latitude. And what you're looking at is his location with regard to latitude. He's at 50-degree latitude. And the 50-degree latitude, the UV should be much lower than anything down south. But it's not. It's always consistently higher. Which in itself is, it's an enigma. Got Kelly asking about the hurricane season. Yeah, the hurricane season, once the dust clears out and the sun angle moves farther south, then you'll more than likely see an increase in hurricanes. And hopefully none of them make landfall. That's the thing. We don't want them to make landfall, but they definitely need to do their job. And that's what hurricanes are. We look at them as hurricanes. That's all we've ever known. Oh, they're these big giant storms. Nah, they're a natural cooling mechanism of the earth. That's what they really are. And that's one question that, here's somebody here, Lurkface. Okay. Okay. Just trying to get a few of the questions up, guys. Okay, yeah, that's Darren. And the higher up you go latitudinally, the lower the UV should generally be. That's just a basic UV 101, if you will. And here's what we're going to look at. And we're just going to use null school as an example because we've got longitude and latitude on here. The green is actually dust. It's very, very thin layers of dust. The brownish colors, the tans are thicker elements of dust. The green technically isn't even supposed to be there. I mean, it is. It's showing us that there's dust in the atmosphere. And that's all from the Saharan air layer. And that's why, in my opinion, you can see right here, there's dust over in Europe, all over Europe. That's why the noctilucent clouds were red. Saharan dust. I'm telling you, it's influencing the temperature of the Earth. Has to be. But we're going to use this for an example, just looking at longitude and latitude. Typically, the UV is highest right here at the equator. Right in here. Both sides of the equator, south of the equator, north of the equator, to say about 10 to 15 degrees north, 10 to 15 degrees south, the UV is generally the highest. All right. The farther you get away from the equator, north and south, the lower the UV is. So let's say we get away from the equator. Let's say the UV down here is 16. I'm talking UV index, and that's not the total UVAB. What we measure is the total UVAB, which is, here's an example right here. This is a reading that Bill sent me from Great Falls, Montana. Great Falls, Montana is at the 47 degree north latitude. Sent me a reading of, actually when he first took the measurement, that was its maximum at 12.6. It stopped at 11.2. That very first reading is always the highest, and then that's where it settled at 11.2, which is an extreme UV reading, okay? And that's at the Great Falls, Montana location, which is, here's the equator, that's way up here, all right, at 47 degree north, right in here. Darren from Abbotsford, the photo that I just showed you guys, is way up in here in southern Canada, in British Columbia. The UV should probably never be above 7 or 8. But I consistently get higher readings from British Columbia, Canada, than I do out here in Arizona, in the desert. Doesn't make any sense. And it's been like that ever since Darren has been sharing UV readings with me. In fact, here's the UV from yesterday, and I'll just share it with you guys. The reason I haven't been uploading the UV videos is because it's just myself, Darren, and Bill from Montana that are taking UV readings 3 times a week, and we do it only in the summer during the summer months because of, you guessed it, the sun angle. It's all about the sun angle. So when the sun angle is the highest, the UV is the highest. When the sun angle is lowest, the UV is lowest. It's just that simple. It's not rocket science. It's really not. So we started measuring the UV looking for, extreme, I'm talking super extreme cases that could be altering things at a cellular level, like altering paint, changing paint from the color red to white, melting outdoor furniture, burning holes in bell peppers. You guys have seen it. So we're just trying to learn, that's all. But here's the UV reading from July 28th. That's UVC on the left, measured in microwatts. Total UVAB on the right, measured in milliwatts. A slight difference, but at the end of the day, it's still UV. That's me looking at the sky. It was 108 degrees that day. There's the UVC, which, you're right, I've had people say that should not be detectable at ground level. And normally it's not, And we could always, have to consider equipment malfunction, I guess, I don't know. Here's the UV index on that day, which was 11.7, which is in the extreme range, which isn't necessarily uncommon for July. It's really not, especially in the Phoenix area. In fact, it's quite normal. July 28th, 2020 at 12 noon. And what you're going to look at is the shadow cast on the ground by the sun angle, okay? And this is July 28th at 12 noon. And I'm using a simple piece of, 4-inch PVC pipe standing on the ground. I use it in the same place at the same time every day. And there's the angle. And the sun angle, or the shadow, is growing, as you'll see here in just a minute. That I definitely have proof of. So this is the measurement of my shadow on July 28th. This is how you can tell if the sun's moving back to the south. It's very simple. It's 5 7/8 of an inch. Okay, that's how long my shadow is at 12 noon when the sun is at its peak. Okay, so we're going to continue on, and I'm going to show you a shadow from right around the equinox. And this is from yesterday, the 28th. And you can see it was 5 7/8 of an inch long, just over 5.5 inches, my shadow. Now we're going to look at the shadow during the equinox at 12 noon, right around the equinox, June 19th. And this is at the 33 degree north latitude. There's the shadow during peak solar and peak sun in the northern hemisphere. The shadow shrank to 3 7/8, just under 4 inches. All right. and that's where it stopped. And then it started growing. So once my shadow started growing, I knew, based off of a simple shadow, here they are side by side, June over here on the right, 3 7/8, July, 5 5/8. See how the shadow's grown? It's because the sun is going back towards the south. It's quite simple, it's not hard. So I do know the sun angle is changing. Here's a reading by Darren from way up here at the 50-degree north latitude. The UV should always be lower than anybody below him, okay? That's just basic UV 101. The higher up you go into the Arctic Circle, the UV is never above 2 or 3. I mean, it shouldn't on a hot summer day in the middle of the summer in the northern hemisphere. His, believe it or not, is starting to go down. 10.6, which was higher than mine out here in the desert, and it usually is. That was taken on the 27th, and it was all blue that day, sunny skies. Here's some other examples from British Columbia sent in by Darren. Look at that, 14.4. That was June 3rd of 2019. That was before we were even at solar peak. June 3rd, 2019. I've never seen a UV reading that high out here in Arizona. Now here's the equinox. See it? June 21st, 2019. We are at peak, solar peak. 14.78 was his maximum UV. This is UVAB, like we're used to seeing down here, ground level. But wow, that's more of a tropical number. Are you serious? That's at the 50-degree north latitude. Unreal. Here's another one from Darren. This is July 13th, and you can see it's starting to go down because the sun angle's going down. So that is consistent. But why is the UV so high up at the 50-degree latitude? It is what it is, we don't know why. Here's one from the 15th of July. And this is of 2020, 12.26. So for some reason, big numbers coming from British Columbia. And it's been like that for 2 or 3 years. Here we're going to Great Falls, Montana, 47-degree north latitude. And Bill's numbers, and these are recent, these are from this year, are consistently as high, if not higher on some days, than mine out here in Arizona. And this is up in Montana, not far from where Darren's at in British Columbia. See, 11.4, 12.7, 12.07 to be exact, 12.6 was his max on this particular day. 12.0 is what it ended up being, which is, tipping the scales. Unreal. And that's why I always say in these videos, I don't sponsor Badger. I don't know anything other than it's a very good product. If you have kids, you're outside yourself a lot, that's one that I highly recommend. And I recommend something as simple as this right here. I've been saying that for years. Carry portable shade. Did you know that the umbrella was initially invented for shade, not rain? Isn't that something? It sure was. Kelly Wasil, I got another question here. Kelly Wasil out of Florida. I was just wondering how bad it's going to be this year. We are still rebuilding from Hurricane Michael. So they're probably in the Florida Panhandle is where Kelly is located, would be my guess. Hurricane Michael was yet another example of a big, powerful storm that occurred in 2018. And they're still rebuilding from how incredibly strong that storm became. And to me, if we had more balance in nature, the the natural cooling mechanisms here, if they weren't being interfered with by all this sand, we probably wouldn't see those types of big, powerful hurricanes. You know, we would see a lot of smaller ones. Category 1s, Category 2s that stay out in the ocean and just do their job. They're just transferring heat around from the long, hot summer. That's just what they do. They're not intended to come barreling into landfall and flood homes and take roofs off and uproot trees. That's what they end up becoming, you know? We don't need this dust. They say, oh, the dust adds... it's great for mineral content, and yeah, it's great for breathing in too, isn't it? You know, the dust is a local phenomenon that needs to stay in the Sahara Desert, because if you've ever looked at the Sahara Desert on Google Earth, there's not too much growing over there, you know what I mean? So Florida's citrus crop doesn't really need an abundance of sand from the Sahara. It's doing just fine, you know what I mean? Doing great. So we don't need all that sand. Soul Vibe, here's a question I'm taking a quick look at. Does the dust add or take away from the electrical charge of a storm? It neutralizes a storm. That's why the hurricanes can't form. It creates a super stable air environment that the hurricanes can't breathe in. They can't go up and expand out like they naturally like to do. They collect that heat and move it around throughout the northern and southern hemispheres. That's what they do. That's why they do it when they do it, at the end of summer. They start in the middle of summer and they go until the beginning of fall. They're transferring the hot summer temperatures around so that it doesn't pool at the equator of the Earth and causing the Earth to overheat. That's why they're really there. That does it naturally. The Earth just does it naturally. You know what I mean? So, let's see, there's Kelly. I'm trying to get as many questions as I can, guys. Doesn't necessarily mean I'm going to have the correct answer, or at least if I can answer it, I'm going to try to answer it correctly. Equine Prepper, is the Sahara dust heading north as well? Yes, you can see here at Null School, nullschool.net, excellent place to follow the dust. Again, all of the green you see here on the globe, check this out, guys. The globe is supposed to be blue. Do you realize that the globe is supposed to be blue, like right here? See? This is way up in the Himalayas. Nepal, see the blue? That's the Earth right there. It's engulfed in a thin layer of dust right now. This right here just happens to be thicker. That's the localized starting point. That's why it's so thick. That needs to have some form of irrigation go through there and keep that dust down. And then the natural mechanics of the Earth can resume their duties, you know? Hurricanes a lot of times start over here off the west coast of Africa, but they're coming off the west coast of Africa, they're trying to, and they're being greeted by a wall of dirt, and then they just flatline. And that goes back to your question about electrical charge. It neutralizes it. So they just stop. And then the heat is all being trapped right in here. And then once the dust leaves and all that heat becomes one big storm, and we see Dorian, we see Irma, we see the Hurricane Michaels, because the heat cannot be transferred evenly. Needs balance. And that's creating imbalance, right? Trying to get some more photos, guys. Or not photos, but questions. Blanca asked about what's up with the rocket. A video was sent to me yesterday from a young lady by the name of Grace. Her son Charles was hiking over in Japan when a rocket was launched. And the only thing I could find, and she found too, was it was a rocket that was headed to Mars. Yes, it was launched by Japan, but it was a mission called the Hope mission that is run by the UAE. That was a rocket from Japan, obviously, but it's engineered by the UAE, and they too are heading to Mars. That's what the rocket was. I was surprised too. I didn't even know anything about it. Pretty cool. Everybody's heading to Mars. And I always have somebody here like Tailish Pixel says the machine needs to be calibrated. Well, then everybody that's ever been a member of Team UV, all their instruments are wrong. Yeah, they're all wrong. And I've had probably 15, 20 members of Team UV. I guess all of our instruments need to be calibrated. They're all incorrect. My thermometer outside that says 110 is probably wrong. Probably needs to be calibrated. It's not right. It's not 110. Of course not. No, you're in the middle of the desert. Why would it be 110? It's not right. Just because you don't agree with it means it's not right. Is that how it goes? Trust me, it's been calibrated and recalibrated by the best. Mark Jones. The UVC, yeah, it's baffling to all of us, Mark. I'll touch on it, but, you know, at the bottom line is this. The ozone, you guys know what ozone is? I'm sure most of you do. Ozone simply oxygen. It's oxygen with part 3. Oxygen at ground level is O2. H2O, O2. Oxygen level up there is O3. That third particle is what manages the UV. It allows long wave frequencies to penetrate the atmosphere, which is UVA and B. UVC is a short wave frequency that doesn't normally penetrate beyond the ozone layer. That's just how the Earth, by default, manages the ultraviolet light from the sun. Well, for whatever reasons, it appears that everybody that's ever measured UV on Team UV that's had UVC instruments, they've all gotten readings of some degree, whether it be, and they're all very small, don't get me wrong, it's not like they're big, but for some reason it's detecting a shortwave frequency. You know, maybe it's something else, maybe it's interference from something else, but everybody's instrument detected some form, albeit small, of a shortwave frequency. So that's all I know. I'm learning too, because I'm trying to figure out, you know, what causes things like that. You know, that piece of vegetation right there, that bell pepper, was in part, and a big part, produced by the sun. And now it's being destroyed by the same instrument that created it, the sun. You know, without the sun, that wouldn't have grown. And direct sunlight, Sherry said this faces the south, and this was in the direct sunlight. That's what they normally like. But not this one. You can see that's singed. Look at that. So when I started getting more and more photos like this, and I have several more, this is just one of the most recent ones. Since we could easily check the temperature, temperatures didn't seem that far out of bounds. It wasn't like we were setting record temperatures by 10 and 15 degrees every day. Temperatures were fairly normal. So we had to find something else that we could measure. So we just started measuring UVC because of things like that. And things like this, what you guys saw, you know, that's an extraordinary example of something that broke down the cellular level of this piece of equipment. There's a lot going on right there at the cellular level. Same way with this here. The cells, the very small cells that we can't see, reacted to something very strong, and they just disappeared. They're vaporized. They're gone. It's like extreme evaporation, right? And that's one question I have about the whole UVC thing and ozone. Are there microscopic, are there small holes in the ozone layer? Is that even possible? You know? I don't know. It's just a thought that's allowing something to come in to alter, you know, devices like this, turning once red stop signs completely white. You know, I don't know. I have questions too. And at least I'm trying. That's all I can do is try. And try to learn, try to become more educated. That's all. not trying to prove a point. Heck no, I'm just trying to learn, just like the rest of you guys. I don't know it all. If I had all the answers, I wouldn't be doing it. You know what I mean? And then Mark Jones has a question. Can you link the Schumann spike to the UVC readings? And that is a no, capital N-O, no. I've tried. And that's a good question, though. That's a very good question, and I'm glad you asked that, because I have tried. Yes, sir. And that is no, I cannot. But that's a good question, because you're talking about frequencies. I know what your mind is thinking. You're thinking of a frequency. And that's an excellent question. But that's one that I could not match up. Nope. Couldn't match it up. Okay, guys, I'm just looking around here at some more questions. Keep them coming. You're all very, very intelligent. You have good questions to answer, and we're all just trying to learn here. I'm not a know-it-all. I'm not the oracle of knowledge. I try to learn just like you guys do. Mixum, forgive me if I mispronounce your name. Mixum Styles is the Earth resonance frequency being affected by the sandstorm. Wow, that's a very good observation. Well, it's acting kind of I'm just thinking out loud here. It's kind of like a neutralizer. It's creating a heavy air layer. Wow. Huh. I wouldn't think so, because it's at a much lower level than where the frequency is measured. I think I don't know. That's a good question. That's a very good question. I suppose it could. I suppose it very well could, especially if it was dense enough. Like if the whole Earth was covered in something like that. I mean, that's very, very thick. In fact, that's 1.8. That is very thick. I mean, you're talking almost full-fledged dust storm right there. We get those from time to time out here in Arizona. But again, keywords being time to time, not constantly like we're seeing here. That's an enigma. That's an anomaly. I remember some dust waves coming off, but never for weeks on end. I mean, to me, that's something kind of new. But that's a good question. I suppose that it probably could. It would almost have to, wouldn't it? Because you have a different element now in the atmosphere. You have a different layer in the atmosphere, the layers of the Earth's atmosphere. That's what that's temporarily creating. And if it's able to influence the formation of Earth's natural cooling devices, which are hurricanes and cyclones, that's what they really are, then I suppose it can influence other things as well. So, great question. Good one. D. Ray, got another question here. Whoops, sorry, I'm trying to read these off of my phone. Do you think CMEs could be the reason why people are really getting ill? What's your thoughts? It seems a lot of plant life is also dying off as well. And I'm going to say no on that, simply because CMEs have been around. I've witnessed solar maximums before where CMEs have just crushed the Earth, and things were just fine, for the most part. There were some solar eruptions back in the early 2000s. I remember after SOHO was launched in 1998, and we could watch these actual solar storms, CMEs, come right at the Earth. I've seen some massive X flares come off the sun, Earth-directed. Things seem to be normal, perfectly fine. In fact, it seems like weather is, just speaking about weather is more, from what I remember right, under control during solar maximum. One thing you have to keep in mind, during solar maximum, it deflects a lot of cosmic rays that are from deep space that keeps them from penetrating the Earth's atmosphere. And that could explain why we're measuring trace amounts of UVC at the ground level because of solar minimum. We're going to see, because once solar maximum kicks back into high gear and we have that steady flow of strong energy coming from the sun, we have sunspots facing the earth. We need sunspots, believe it or not. Yes, we do. That cuts down on cosmic rays, harmful cosmic rays. So we'll see when solar maximum returns. I'm going to take a wild guess and say when solar maximum returns, that UVC, those trace amounts, will disappear. I think that's why they're here, to be honest with you. I really do. That's what I believe. All right. Let's see. Because I think it's influencing the shields of the Earth, obviously. Okay. The unbridled rabbit. Are we going to have Planet X inbound anytime soon? And is this what is causing everything? Well, here's the deal with Planet X. We have planets behind us, next door, in front of us, all the time. We got Venus right next door. Mars is our neighbor. And they don't seem to be turning the Earth upside down. Jupiter is a big gas giant that I know influences the Earth to some degree because it's a big gas giant. It has a huge electromagnetic field. And Earth, again, is not doing cartwheels, and we're not having massive tidal waves all over the globe just because we go by a planet. We have planets near us all the time. So unless Planet X, which I haven't seen it yet, is some massive planet about the size of 10 Jupiters, and even then it would have to come very, very close to the Earth to have any type of significant influence at all. Just look around your cosmic neighborhood. You got planets around you already. So, I don't know. I've never seen Planet X. Boss Lady, my question. How are you, Mr. MBB? I'm doing okay. How are you, Boss Lady? Thanks for asking. Doing all right. Hanging in there, I guess. H.A. Faber. I'm going to go with Faber. Sorry if I mispronounced that. Could a solar micronova cause earthquakes of biblical flood proportioned magnitude? Absolutely. Gamma rays, micronova, I suppose they probably could. I suppose they could influence that anyway, yeah. Saw a nova one time years ago. Sure did. Or something like a nova, pulsar. Saw it 90 different times, same place. Evan Clark, based off of what you've been observing, do you think that nature slash storms will get worse in parallel to the weakening moment of the magnetic field? Yes, sure, absolutely, we're seeing it. We're seeing like this dust traveling across the Atlantic. That's probably a side effect of solar minimum. Once solar maximum returns and gets a handle on things, then a lot of things should return to normal, or at least what we've known. This dust traveling for weeks on end into months, people breathing it in, I don't think that has one good component to it. I really don't. I'm sorry. That's causing the Earth to overheat. That needs to go. No joke. That thing needs to go. It's causing the Earth to overheat. Here we're back at the Schumann Res. In fact, let me update it and see if the signal's gotten any bigger. It has. It's still there. And that doesn't appear to be solar influence. What I mean by that, it's not apparent that that's from obviously a sunspot, because there are none. There is an slightly Earth-directed coronal hole, but that energy is not here yet. So, don't know, but we've still got something resonating with our planet. I wanted to go over here real quick and look at the wildfires up in Siberia. You can see them here on Zoom Earth. They're parallel from Canada, and they are at the 150-degree latitude that we learned the other day, just like the wildfires in Canada last year and into this year, 2020, We're also at the 150 degree latitude. That would be 150 degree east. And here they are. You can see them at Zoom Earth. The ice completely gone that you could see right here along the shorelines. There's the smoke right there. See it? Or see them? Look at all those. And again, that's something that is fairly new. Probably, I'm going to go 50-50 on this. Solar minimum. Once solar minimum, because we're in a deep solar minimum. I think this could be influenced by solar minimum. I really do. That's June 28th. There's June 27th. Just massive wildfires up here in northeastern Siberia. I mean, those unbelievable. And they can't get out there. Well, I don't think they even try to manage these wildfires. Here, if you go back to May, and again, it goes back to sun angle. Everything's about sun angle, man. May 27th, you can see ice here along the eastern Siberian Sea. Look at that. That's May 27th. Hop up 1 month. It's almost all melted. Go up to July, and those are clouds. That's smoke. Look at that smoke. The carbon monoxide there is just off the charts. In fact, we'll come back and take a look at it, but there's the 25th, and you can see the blue sea right there. There's no more ice. It's gone. Completely melted in right around 30 days. And that was right at the peak solar in the northern hemisphere, the equinox. Sun angle. It's all about the sun angle. I want to check let's see here, where we at? Chemicals. Yeah, there you go. We got wildfires burning, seems like constantly over here in Central Africa. That's another hot spot. And that's just below the equator. See right there? Just below the equator. That's constantly, there's hundreds, quite possibly thousands. I know there's hundreds of wildfires over here in this area. We're going to hop up to this area here. Oh, wait a minute. What's going on over here in Alaska? Hold on a minute, guys. Okay, that's carbon monoxide. It's carbon dioxide. And that's sulfur dioxide. We want carbon monoxide. Okay. There they are right there. Actually toned down a lot compared to what it's been. But that's the wildfire smoke, carbon monoxide output as of today, right now. But it has been exponentially thicker at much higher levels at 12,000 parts per billion just less than a week ago. It was black over here, jet black, very dark purple, covering a huge area, many square miles. But that's at the 150 degree east latitude, just like the wildfires in the southern hemisphere. In Australia, the record-setting wildfires were at the 150 degree east latitude or longitude. But the Saharan dust started at the same time the equinox was, and now that the sun's moving back south, has to be influenced by the sun angle. And once the sun angle gets down closer to the equator, I think this will dissipate just like it did last year as the sun angle dissipated. Have to wait and see. But here's the storm we were talking about earlier. It's not a named storm yet, at least not named that I know of, unless it's happened within the last hour and 15 minutes. Last time I checked, it was just a semi-organized, very large low-pressure system right here. But as you can see, this is a chart from the National Hurricane Center. These are the professionals this is what they do. They follow these storms 24 hours a day, 7 days a week. And they're showing this all S's. Starting later on today, this thing could become a named tropical storm. And I'm not even going to attempt this next name. I will, just for fun's sake. Aya Oasis or something like that. I don't know. It's something I've never even heard of it. But see all these S's? All the way up into the Gulf of Mexico. And that's a 5-day forecast. 5-day forecast, like any forecast, they're subject to change. And it will. It's going to change to some degree. Is it going to go further to the west? Maybe take a southerly track? Westerly track? Will it go to the east-northeast? Don't know. Will it take this exact path? That's always a possibility too. But right now, this is what we're looking at. And if it does take this path, it's going to take basically the path of least resistance, because there are some mountainous areas in southern Cuba. It's going to go right over the Dominican Republic, which there are some mountainous regions there, believe it or not, that are in the neighborhood of 10,000 feet. That will influence the mechanisms of this storm as it's trying to become a hurricane and transfer heat like it's supposed to do. That mountain's going to keep it from doing that. Then as it moves farther to the north, up in here, it's going to encounter a little bit of land, not much, but some. Still going to be over very, very warm waters, some of the warmest waters on Earth. And then entering the Gulf of Mexico, which you guys are all very familiar with. It's like a giant bathtub in there. So minus wind shear. If there's no wind shear come this weekend, Saturday when it's over the Florida Keys, Sunday, this thing has the potential to increase into a hurricane if there's no wind shear. And right now, according to the wind shear maps, there's no wind shear in that area right now in the Gulf of Mexico. Can that change? Absolutely it can change, and it will. But just how much, we'll have to wait and see. But right now, this is a forecasted model based off of the presence of wind shear and the presence of the Saharan air layer that's obviously right there in front of the storm. They're still giving this thing a chance to become a named storm. All things considered, and that's including, like I said, wind shear, which is right here, and there's a ton of it. All those red lines you see, that's wind shear, and in fact, heavy wind shear in some areas. Still becoming a tropical storm. If that wind shear were not there, you'd probably have a minimal category 1 or 2 hurricane, actually quite large, on its way to a major hurricane as we're doing this video, but it's not because of the wind shear and the Saharan air layer. So it's keeping that storm from transferring heat around. And if you'll notice, every storm at the last part of its journey, where does it go? Like for instance, this one here, if I can put I don't know if it's got any, no it doesn't yet, it doesn't have any directionals on it, but they all go to the North Pole. That's where they all go. Every single one I've ever seen, North Pole bound, right here, like this one here you see, it's traveling to the northwest, and then what does it do? Turns to the north, just like they all do. That north is towards the North Pole. So that's what these things do. They try to keep the heat in the northern part of the globe balanced out, to some degree. That's what they do. That's why they form. But that dust layer is definitely putting a lid for sure on that. It definitely is. And it's causing the earth to a certain degree overheat. That's just my opinion. I'm going to take a few more questions here, guys. I'm trying to keep up here with as many as I can. Paul Ross, what's up with the moon? Gravity, I should imagine. Let's take a look at the moon. I had someone ask me yesterday. They thought the moon looked like it was a full moon, and it's not full moon phase yet. No way. If you go to the website, which you can also find linked below in the description box, and I've got a moon tab right here, moon phase. Moon phase is very important to the functionality of everything on Earth. It has an influence on how things grow. Farmers actually plant their crops at least a lot of farmers. And in fact, I knew some farmers that planted their crops according to certain moon phases. And right now, July 29th, we're at 72%, waxing gibbous. So no, we're not in full moon phase yet, but I had someone yesterday ask me why there was a full moon. Did anybody else see a full moon? I didn't see a full moon. In fact, I saw a daytime moon that was not full, but I don't know. If it was full, I don't know how. Full moon's not going to be until like September 3rd. Let's look. I'm sorry, not September. August, right there. August 3rd is when the full moon is. So we've still got about 5 days before we see a full moon. But someone yesterday, and I forget who, I'm sorry, I don't remember, but said they saw a full moon, which was quite a surprise to me. I did not know that people were seeing full moons. Great Epiphany. What caused the dust storm? Sun angle. Sun angle. Everything's about the sun angle, guys. Everything's about that sun angle. If you don't remember anything else I ever said, just remember sun angle. Because without that sun, there ain't much happening around here, good or bad. Mary Matauchi, what's up with the moon? Okay, someone else is asking me now. This is Mary. What's up with the moon? That's a good question. I don't know. I have not seen the full moon. I've had someone say that they saw a full moon. Dave Moran, do you think the solar minimum is affecting humans? Absolutely. Sure. Both physically and mentally? Absolutely. Yes, we're all part of this system. We're part of the Earth, Moon, Sun, star system. We're part of it. We're in it. We live it. We're part of this whole system. Yes, you feel every move it makes. Absolutely. The moon, the sun, and the Earth. And the electromagnetism in Earth that surrounds Earth, the geodynamo, you feel every bit of it, my friend. Every bit of it. Does it affect you? 100%. You're a biological walking antenna. So am I. And it's impossible for you not to be affected by it. You could go underground and still be affected by it. Yes, sir. Very good question. Real one. Do I think, and again, I'm not the oracle of knowledge, guys. I want to make that perfectly clear. But I have been studying for a long time. Okay, do you think during a solar minimum that wearing a mask is more dangerous during a solar minimum? Well, I don't think wearing a mask is good for you. It's kind of like the dust, okay? Earth is over here trying to breathe. These storms that we call storms, they're coolers. They're natural cooling systems of the Earth. Any planet that has these cyclones spinning up, and it would have to be a planet that more than likely was covered with some form of a liquid. Earth is H2O. And then it forms evaporation, which forms clouds, which form weather systems, and it's all a natural process. These are coolers. These are cooling engines that are trying to disperse heat. When the Earth can't breathe, these things can't do their job. If you run around with a sheet over your face, you can't breathe properly. So no, I don't think it's. I think it's helping you in some ways, but I don't think it's equally as good in another. Again, we have to find balance. We have to find balance. I know when I wear one, I just wore one today. Not even gonna comment. Insight Benez. There was a meteorite that hit near Santa Fe, New Mexico last night. Really? Right on. I'm not surprised. You know, I've never seen a large meteorite. I've seen small ones. Saw a red one, a red and gold one time. That was really, really cool. Wasn't very big. Lasted maybe 3 seconds. But man, it was really neat. Simon Foster. Greetings from the UK. Hello, Simon. I am intrigued by these unusual patterns in the sky. At the moment, at high altitude. Any thoughts on the reasons for these patterns? I can't see them right now, buddy. But yeah, I'm pretty sure I know what you're talking about. But I don't know. I can only guess and theorize, and I'm not going to do that too much, you know what I mean? Because again, like I just said, I'm not the oracle of knowledge. I'm an observer. I've learned a lot over the years, you bet. But I have theories just like you guys. Okay, Catbird singing. Do you think the Earth is changing axis as the sun rises in the northeast? That's happened slowly. Yes, of course. And here's something for you to think about. What if, as the Earth is traveling with the sun through the galaxy, you got to look at the whole big picture here. And you have to include the galaxy because we're part of it. And the center of the galaxy influences everything in the galaxy, right? So if we are above, of course, we're following the star. That's why we're orbiting the stars, because we're part of the star system. And we go where the star goes. So if the star is traveling through the galaxy above and below the galactic equatorial plane, do you think that would have an influence on the planets that are following the star? Especially magnetically? Absolutely. Or at least it should, right? Should. So what if the star, talking about the sun, was at its peak with regard to traveling through the solar system, through the galaxy, through the Milky Way, and it's peaked above the galactic plane of the Milky Way galaxy? Would there be a different type of energy up there? Of course. Yeah. Would be a higher energy, probably a higher frequency, a higher vibe. And then over the next few thousand years, I don't know how long it takes, the sun will slowly go back down to the equatorial plane of the galaxy and then below, where the frequencies along the way will change, right? I'm going to have a guy on someday to talk about that. Now, he's the guy that wrote a book about it. I didn't write a book about it. I read this man's work. His name's Jamal. Jamal is a very, very intelligent man. And we're going to talk to Jamal about that, I guess, theory, so to speak. But theory based off of observations. So we're going to talk about that. It's called the helical sun model. Helical. And, you know, I look at it, and I kind of like the helical model. I do. Trying to keep up with a few questions here, guys. But yeah, what if we're at the peak? What if the star has risen as high as it's going to go in the Milky Way galaxy, and it's starting its journey slowly but surely back down? Because we follow the star around. That's part of it. Stephanie Kerr asks, how far off is the sun angle? Don't really know. It does appear to be farther to the north. You know, I know it does at times. Depends on your location. If you're in certain parts of the world, it probably looks the same. It's hard to say. It's hard to say. One thing that I think would be a big indication would be noctilucent clouds. If you pay attention to noctilucent clouds and you're up in the United Kingdom and you've seen earlier noctilucent clouds, those are going to give you clues. Okay, noctilucent clouds. Those are going to give you clues. Clues. Okay, how does the... Here we go. Pickled Grammar. This is a question from Pickled Grammar. How does the sun cause earthquakes? I don't quite understand it. Well, the sun causes pretty much everything. You know, like I said earlier, without the sun, there wouldn't be much happening around here or anywhere else in the solar system. So the sun kind of does whatever it wants. Doesn't necessarily directly cause earthquakes. You know, earthquakes are ultimately caused by tectonic plate movement, which is influenced by thermal energy in the earth, and you know, could be influenced by cosmic rays, gamma ray bursts, could be influenced by... There's a lot of things that in conjunction with the sun that cause earthquakes, of course. It's not just one single thing, but I think the sun does play a part in it, absolutely. Take the sun out of the equation. Just sit back someday and take the sun out of the equation. What's happening on Earth? Probably not too much of anything. Nothing's going to grow. You're not going to have weather patterns stirring around the globe. There's just not going to be too much of anything happening at all. So, yeah, the sun definitely has a big play in it. Sure. Okay, I'm on script. Lala HK. Will you look at China and the flooding? You know what? I saw that, and I saw that last year as well. There's big time flooding over there. You're exactly right, and that does occur over there often. At least I've noticed once a year. It seems like they have big floods in very densely populated areas. Unfortunately, trying to go through some questions here, guys. Bear with me, please. I'm trying to answer as many as I can. That I can't answer. Can't answer them all. You guys are smart. Man, you're smart. Okay. You guys ate your Wheaties this morning. That's good. Okay, L.E.K. Patton. This is just another question. There's no such thing as a bad question. L.E.K. Patton. Or Peyton, I'm sorry. But more is happening. Are you here to hold the status quo, Mr. MBB 333? Does the BB stand for 22? What's up? Get some... Oh, come on, don't be paranoid. You're acting all paranoid here. I'm on your side. There's not a side. We're all in this together at the end of the day. Flying through space on this thing we call Earth. So, no, the BB's just my name, dude. That's all it is. Okay. Got another question here. Whoops, sorry. That's Lala from the flooding in China. And yes, there is some big flooding going on in China. But what do you guys think about the helical sun model? The helical sun model. Just look it up sometime. Helical sun. Jessica Smith. Here's another question. Question from the United Kingdom. Do you have any predictions for winter this year based on my readings? Well, since we're in solar minimum, I'm just going to base it off of that. Look for probably a wild winter. Yes. We're having a lot of... We've set a lot of heat records over here in the U.S. This year. It's been very wet in certain parts of the country. A lot of heat records. And heat extremes, because we're out of balance. You can see why. Look at the dust. Good grief. That needs to stop. It's got things out of whack. Come on, man. So yeah, you're going to see extremes, right? There's another example why. One day it'd be 90, and the next day it'd be 60, and 30-degree temperature swings, and smashing records that are 125 years old. But if you'll notice, a lot of the records that are being broken with regard to temperature were set during previous solar minimums. Ding, 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 ding. See the connection right there? So yeah, solar minimum, you're probably going to have a wild winter, or at least at times. Okay, here's a question from Sweet Butter. Does the dust storm have anything to do with tornadoes and hurricanes? No, it doesn't have anything at all. The wind's not over there blowing constantly. That's what you would think when you look at it, right? But no, it does not. In fact, it decreases their formation, if you want to know the truth. That's caused by the sun angle. Everything's all about the sun angle. That's why you have seasons. That's why we have seasons in the northern hemisphere, southern hemisphere. That's why the weather at the equator stays the same. Because why? Because the sun's always there. it doesn't really change a whole lot. I mean, it does, but they always have a pretty good dose of sunshine. So they have a lot of rain. They have tropical rainforests. It's always warm, to where in the northern hemisphere, the sun drifts south, and what happens? The northern part of the globe, it gets cold, and we have winter. We have a season. It's all about sun angle. Everything. Take the sun out of the equation, you don't have no angle at all. Ain't nothing happening. D. Ray, explain the helical sun model. We will. Robin Mossler, what's your thoughts? What's your thought on pole shift and the video that gotten taken down by the military guy who said the moon was going to be hit? Love your channel. Thank you. That's very kind. I don't know anything about the moon being hit. But you can tell by looking at the moon, it's very tough. Wouldn't be the first time, right? Okay, so I don't see why that's a big deal, because the moon's been hit many, many times. Pole shift, based off of what I've read, pole shifts have occurred over the years. They happen. It's just part of the existence of a magnetic planet, right? Have I been through one? No, none of us have. Nobody watching this video has. And anybody that says they know exactly when the next one's going to occur is not being truthful. I'm not going to sit here and say I know, because I don't know. I don't even know when the last one occurred, to be honest. The polarity of the sun changes all the time. Did you guys know that? Yeah. Happens all the time. Exactly what goes on Earth, there's two different kinds. There's a polar shift, and then there's a geophysical shift. So, yeah, we don't want a geophysical shift. A magnetic shift may not even know it. You know what I mean? Kelly Robertson, talk about light coming out of the black hole. Talking about light coming out of the black hole. I didn't know light could come out of a black hole. I didn't think anything could escape a black hole, and that included photons, right? Unless there's something new out there I haven't heard of, I didn't even think light could escape the grips of a black hole. I'm not sure what you're implying there, Kelly. I don't know what that means. Sorry. Frank A., do you think the double rainbows are a result of the changing poles? You know what? That's a very good question. I think there's a dynamic that's changed with the light and how light is managed on the Earth that's creating this double rainbow phenomenon. Contrary to what many people may say, that, oh, every rainbow has always been a double rainbow. Let me tell you something. I grew up outside as a kid, and I've spent thousands of hours outside, during rainstorms, whether it be heavy, light rain, heavy rain, flooding, snow, you name it. I've been out in the elements a long, long time, and I've seen a lot of rainbows after thunderstorms. Never growing up did I ever see a double, ever. And we all looked for them, after a storm. That was just something that we did. And we could find them, absolutely. Never saw a double until recently. But yet, I'm told, oh, yeah, they're all double. They've always been double. I've never seen a double growing up, man. Never. Thousands of hours outside. So to me, it's the way the light is being managed, which could be something that's influencing the atmosphere, and how light and color is managed that enter the atmosphere, especially photons. And it's creating this double halo. They're really cool. A double rainbow effect. Something has definitely changed. I know that. Because they're quite intense. And we even see some that are purple and light pink. We saw one over in the UK here recently, about a month or so ago, that looked like a beautiful gateway, a portal just opening up in the sky. Lady filmed a video of it forming right up here in the United Kingdom. Pretty cool. Maybe it's something in the atmosphere that's causing maybe it's a particulate in the atmosphere that's making the secondary rainbow appear. I had a lady send me a picture a couple of years ago of 8 rainbows in one place in Pennsylvania. I mean, it was unbelievable. 8! 8 shafts pointing up out of the ground, going in all different directions. One of the most amazing things I've ever seen. In fact, I had to check on it to make sure it was, even real. Didn't look real. Never seen anything like it. And those are things that you remember. And growing up as a kid, playing outside, growing up, that's all we did. There wasn't anything else to do. There wasn't video games to sit inside and occupy our time. We spent time outdoors, period. And trust you me, just like today, I would have remembered a big, spectacular double rainbow in the sky if I'd have seen one. Never saw one and was in plenty of thunderstorms. Okay, Kathy, question. What does the moon seem in the wrong spot further south? It's orbit around the Earth. I've noticed that myself every once in a while during a lunar cycle. The moon for a few days, not constantly, seems like it'll go a little farther to the south and then it'll come back up towards the north to where it's directly overhead. It never goes directly north of me. I've never ever seen that, but I have seen the moon almost at zenith, directly above my head, and then it'll drift south over the course of 10 days or whatever. But yeah, I do notice the wild swings from south to north. Absolutely, I've noticed it too. Don't know exactly why. Just looking through some more questions, guys. You're asking very good questions. I wish I had the answers to all of them. I don't, but I'll try. Linda Vandenberg. Here's a question. Why are we seeing shadows? Okay, I can answer this one. And it is quite incredible. Why are we seeing shadows against a blue sky? Incredible. And it is. It's really neat when you see it. It's a thin layer of clouds up there. Maybe it's associated with something to do with the ozone layer. Maybe it's got something to do with this Saharan dust. But there is a layer that's able to reflect light and create a shadow, or causes a shadow up in the sky. You'll see it sometimes with an airplane if it's at just the right angle. If the sun is low on the horizon and an airplane is flying in a certain direction away from, and sometimes actually away from the sun, it'll cast a shadow, a reflection, off of the top of the plane, which will create a shadow, a dark beam, up in the sky. I've seen it myself. I just took a picture of it myself about, where were we at? In July? It was back in June. I saw it. I've seen it multiple times. And it's a thin layer. There's many layers to the atmosphere. The atmosphere is like it's like a hamburger, I guess. You've got top bun, and you've got lettuce, tomato, pickle, cheese, whatever you like. All these different layers of the atmosphere reach way, way up. And, maybe during solar minimum, maybe there's a new type of layer that's just there temporarily. Maybe it's just a localized phenomenon. Maybe there's something in the sky that's a thin layer of smoke or something way up there that we can't really see. It looks like a blue sky, but there's a thin layer of something up there that's able to create a shadow. And I know what you're talking about. I too have seen that myself. And it's kind of neat looking. No doubt about it. I'm very intrigued by sky phenomena. You bet. I'm a sky guy. I have been for a long, long time. All right, here's the Zoom Earth wildfire smoke. And this is a great tool here if you guys have never used it. I'll link it down below if you haven't. It's just basically zoom.earth. But here's the path they're showing, and they're probably just following the lead of the National Hurricane Center. But they're showing this new system that we have down in the Southern Caribbean, right down in here by the Lesser Antilles, right in here. They're showing it in the Gulf of Mexico if it stays on this current path by Monday at 5 a.m. during the overnight hours of Sunday. Actually, Sunday in the Keys, Sunday afternoon during the overnight hours, early morning hours in the Gulf of Mexico, and then being in there for a day and a half So if it's in the Gulf of Mexico for a day and a half, you know what can happen. We'll have to wait and see. That's the storm that we'll be watching, sitting on the edge of our seats, because that one could become a big-time storm. We'll just have to wait and see. That's the prime area, and that water is more than warm enough to produce an overachiever. That's what I call them, overachieving storms. If we had more balance in here, and this dust wasn't blocking in heat and everything, I think you would see a different type of mechanism with regard to the formation of hurricanes. But I'm telling you, that dust is just screwing stuff up. It needs to go. Earth can't cool itself off. No, it's getting overheated in through here. And then you end up with these giant superstorms that are just record-setting, like Dorian. I'd never seen anything like that. Wow, that was an unbelievable storm. So this one here, let me look and see if it's been named yet. We might have a named storm here. I don't know. No, not yet. Still, let's go here. Wait a minute. Let's go here. Nope, it's still I guess low pressure, really. It's not a named storm yet, but definitely has the potential to be, for sure. If at the very least a tropical storm, it could be more than that. Take a couple more questions here, guys. Let's see here. You guys have eaten your Wheaties today. You're all very bright. Jessica Smith, question from the United Kingdom. Hi, did anyone send you great images of Neowise comet when it made its close approach to Earth? Yes, I've gotten several. Thank you, Jessica. In fact, my son and I got to see it ourselves, and I got good pictures from northern Arizona. Couldn't really see it down here in the Phoenix area, but in northern Arizona, it was prime for viewing up there, and it was quite spectacular, and it was very, very green. So I got to share that experience with my son. That was really cool. Thanks for asking. Let's see here. Ian Sharp, do you think climate change is a natural cycle? Absolutely. The climate's changed ever since the Earth was early conception of the Earth. The Earth has been changing since first light. Time is nothing more than a management tool of humans. Time doesn't even really exist. It's something that we have to function on Earth and to have organized chaos. We're still on first light. And ever since that first photon hit the Earth, it's been changing. That's why I say if you take the sun out of the equation, then things aren't going to change too much around here. The Earth would be a very stagnant, boring place. But as long as we have photons radiating the Earth, then the Earth is going to constantly evolve and constantly change. Absolutely. Great question. And Earth is going to change with or without us. That's just the way it is. Okay. That's just my 2 cents worth, you know. I'm not the oracle of knowledge, but that's just what I think. Seek all truth. Can 5G affect UVC or even control it, since they're both shortwave frequencies? And again, you know, that's a great question. And, you know, maybe these instruments are picking up 5G. Shortwave, you're right. You're very observant. It's a shortwave frequency. So is that what we're detecting? You see what I mean? These instruments aren't miscalibrated, okay? They're detecting something. That's what they're made for. Okay. So great question. Thanks for asking. Awesome Bill. He can call me paranoid if he wants, but there is a fact. He either doesn't know about Nibiru or won't say. What a watchman. Bill, come on. Okay. Diane DeClerc, I hope I pronounced that correctly. Okay, here's a legit question. They're all legit questions, okay? Where is the heat coming from, and why is the Earth harnessing it within the core? Well, how do you know it's harnessing it within the core? Have you ever measured it? The only thing I can measure is the outside temperature, how much it rains, and UV. I've never measured the temperature of Earth's core. So you're getting information from somebody that must have equipment that can measure the Earth's core. I don't. I don't have that type of equipment. Not sure I'd want it. But, it's a good question. But how do you measure the temperature of the Earth's core? I don't know how. Here's another question. And again, it's referring to the core of the Earth. Again, guys, how do you monitor the core of the Earth? That I have to ask you. I could sit here and make stuff up. I don't want to make something up. I don't know. Corey Anderson, MB, you should just have someone from Raytheon to answer questions. I don't think they'd have time for me. Let's see. Here's another question. Anto B, what about Schumann's resonance at the moment? And I know we were just looking at that, Anto. Yeah, there's an obvious spike in the Schumann resonance right there. That's something we check every day, multiple times a day. That's why we have it at the website. That's just part of our experience on planet Earth, Schumann resonance, and we're all affected by the Schumann resonance to some degree. It gets kind of complicated. I did a study one time years ago. I did it by myself, but it took a whole team of people to really do it effectively, so I never really finished it. But I was trying to understand the effects of coronal hole energy, the sun, like sun spots and things like that, and because it's a different type of energy that interacts with the Earth, and anything that interacts with the Earth, we feel. So I was trying to understand how that energy made us feel as humans and part of our experience as a human in human form. So it goes down to this. It goes down to what type of chromosome you have, whether it's male or female, your blood type, where you live, your diet, what's in the ground, where you live. Do you live in a environment that has a lot of copper content in the soil, in the ground around you? Is it able to conduct electrical current? All kinds of things. There's so many variables involved in becoming, forming a legitimate conclusion that it was impossible for one person to do. Because I found all of those things were important, and they all played a role. So you can't just assume that the resonance affects everybody the same, because it doesn't. It affects everybody a little bit differently because we're all unique. We're all unique. Yeah, we're all human, and we all share the same planet, and we all need to learn to get along, really. That's a whole other subject, though. But at the end of the day, we're all affected differently by the energies that interact with our sun, our Earth, our solar system, and even our galaxy. Our galaxy has a main frequency from the core, So all of those are great questions. But when it comes to the Earth's core, I can't go there, guys. I'm just being honest with you. How do you measure the energy from the Earth's core? Can you buy something off of Amazon to do that? How do you do that? I stick with things that I tangibly know that I can achieve, that I can accomplish. Like the UV. You can buy those instruments and learn from those instruments, I can't buy an instrument that can measure the temperature of Earth's core. So I can't really comment on that too much. We can monitor seismographs. These are a wealth of information. If you look at these, you can see so many different things. These seismographs always have a story to tell. Just like the Schumann resonance. It's trying to tell you something. It's telling you something about your planet. Just like these graphs, they're telling you something. They all have a story to tell. There's all kinds of good data here at spaceweather.com. Awesome website. Use it every day. You know, this is one of my favorite satellites here, the GOES full color geocolor disc. The GOES 16 is one of my favorites anyway, and this is just one segment of the GOES 16's many features that it has infrared, visible, different types of water vapor. It is a awesome piece of equipment, and I use it all the time as well. But back to this here, guys. What I started this video off with about this bell pepper that was sent in from about the 40-degree north latitude, and that's where Toms River, New Jersey is at, and that's where that pepper came from. And at the 40-degree north latitude, the UV, at least with regard to UV index or the total UV, shouldn't be that high to influence that type of vegetable to where it would burn a hole right through it. So, you know, what caused that? You know, you tell me. I'm trying to learn too. Something very intense interacted with the cellular structure of that bell pepper that caused the center of it to just collapse. It just vaporized. It's gone. Just like the rocks that I showed you in the earlier picture. Right here. Young lady walking by a creek. And she's walked this creek her whole life in West Virginia. All of a sudden the rocks have scorch marks on them. She said it wasn't a campfire. So I have to take her word for it. I mean, I'm not there, but if she's a sincere person, then that's, you know, that's pretty bizarre. You know, you don't see that very often. But you have to consider, you know, could there have been a piece of coal there that just spontaneously combusted? I mean, wow. You know, that's some pretty strong sunlight if that is in fact the case. Darren from up here in Abbotsford, British Columbia. You know, we get UV readings up there. I get them 3 times a week is what we do. And again, like I started the beginning of the video with, you know, his UV readings up there are consistently higher than mine, and I'm 17 degrees further south than he is. And basic UV 101. UV is highest at the equator, lowest at the poles. So when you go up, the UV should be lower, not higher. Kenneth Johnson asked me a question. Have you been censored, sir? Not that I'm aware of. I don't know. Corey Anderson. Corey Anderson says measure the temperature of moonlight in shadow with digital thermometer on pavement. Moonlight is colder. Measure it on pavement? I'll do that. I'll check it out. Great observation. Here's James Burke. How is the sand from the desert of Africa able to blow across the world? Yeah, that's the million-dollar question. It gets carried by the winds aloft. Those are up in the 5,000, 10,000 foot range where there's a constant flow of wind, not like we have at the surface. Surface winds are sometimes zero. You know that from living on the surface of the earth. And then some days the winds are 10 knots, 20 knots, 20, 25 miles per hour. You know, steady flow, right? Well, you go up into the upper mid-levels of the atmosphere like I talked about earlier. The atmosphere is like a layer of a hamburger, all right? So are layers of wind. And you can go up here, I'll show you an example here at Zoom Earth. We'll go over to, where are we at? Air. See these numbers here? Those represent height. 1,000, 850, 700, 500, 250, 700, 10 being the surface. Each number represents, okay, like 100 feet, 2,000 feet, 5,000 feet, 8,000 feet up in the air. And the higher up you go, the stronger the wind currents are. We'll go up into the, here we go. Like say for instance here, let me back out of this here. See the winds constantly blowing. This is just one example. The winds are much stronger higher up you go. Like these are blowing at, let me see, I lost my thing. Probably around 100 miles an hour. Doesn't say. Just trying to give you an example of the different winds. But here we go. 18 kilometers, 72 kilometers, 109. I can go to miles per hour. 68, 118. But yeah, I question that too with regard to, my main thing is the natural jet stream in the northern hemisphere generally travels, looks like Medusa up and through here, man, west to east, right? Like you see right here. But yet this dust is traveling from east to west. You know what I mean? So there's apparently a layer of air in there that's able to carry and keep these sand particulates aloft for many thousands of miles. Here you're looking at, see the wind currents down there? That's wind. Look at that. Good grief. Huh. Got to be honest, I look at this all the time. I've never seen it quite that big. Alrighty then. Yeah, that's a good question. I too ask, how do they stay aloft like that, especially going against, right there you just saw the jet stream. Great question. But I have to just try to apply common logic to everything I look at. And when I look at that, I do know that there's steady winds the higher up you go into the sky, whether it be, 500 feet or 5,000 feet, the winds are stronger. That's why airplanes can fly from Los Angeles to England quicker than they can from England to Los Angeles, because they're going with the winds at 30,000 feet. You see? And it takes longer and takes more fuel to fly from England in the United Kingdom to Los Angeles. It takes more fuel because they can't use those winds to their advantage. So, great question. Yeah, right. All I know that this is inhibiting the Earth's natural cooling process that occurs in late summer up until the fall season in the northern hemisphere from doing its job. These things need to keep the Earth cool. That's what they do. They spread heat from the equator up through the cool waters of the North Atlantic, and that keeps the Earth cool. Right now, they're not able to do that with all of this steady flow of dirt and dust traveling across the Atlantic and thousands of miles. And keep in mind, this should be blue, right? It's blue right here. That's the color of the globe on Null School, typically. But here recently, we've had a steady flow of Saharan dust just swarming the Earth to some degree of thickness. Like right here, it's very thick, and over here, it's obviously very thin. This thin layer doesn't necessarily prevent hurricanes and typhoons over here in the Pacific from forming. We just saw Hurricane Douglas go very close to Hawaii. Didn't do anything, but it did its job. It transferred heat from the equatorial region up into the cool waters of the Pacific. And then the heat was transferred around equally, right? Not happening over here, but it needs to. All right, guys, I want to thank you for your great questions. I got sorry, I had the wrong picture up. What I was showing was how the storm over here in the Pacific Ocean, which this light dust, that's what the green is. It's a light layer of dust. Was not inhibiting the hurricane from doing its job. And that hurricane transferred heat from the equator all the way up past Hawaii up into the North Pacific Ocean to where it's cool. That's why it took the heat up there, so it could disperse it evenly. So that makes for a nice climate out here in Hawaii, because those cooling mechanisms, those what we call hurricanes and cyclones, can do their job. Over here it's hot, it's thick, the air is uncomfortable, and it's inhibiting them from doing their job. So anyway, that's my 2 cents, guys. Thanks for your great questions. I really appreciate it. And we'll do it again sometime. You guys are wide awake and on the ball. Great questions. I appreciate it. Thanks for watching. Have a super day. And be safe out there.